Hello and Assalamualaikum everyone. My name is Nurul, Nisa, Maisarah, Binti, Mohd, Rafi, and my partner is Siti Nakibah Binti Azman. In this video, we will present the solution for CS1123C Assessment 3, which consists of question 1 and question 2. We will explain both questions clearly. We begin with question number 1. In this question, we are given a discrete joint probability distribution defined by fxy equals c x plus y, where x take the value of 0, 1, 2 and y 1, 2, 3, also 0 elsewhere. We begin by finding the value of the constant C and then constructing the joint probability distribution table as required in part A. Since this is a joint probability distribution, the sum of all joint probabilities must equal 1. This means we sum the expression C times the quantity x plus y over all possible value of x and y. When x equals 0, the value of x plus y are 1, 2 and 3. When x equals 1, the values are 2, 3 and 4. When x equals 2, the value are 3, 4 and 5. Adding all these values give a total of 27. Therefore, C multiplied by 27 equals 1, which gives C equals 1 over 27. Using this value of C, we now construct the joint probability distribution table by substituting C equals 1 over 27 into the expression C times the quantity x plus y for each possible pair of x and y. Next, we determine the marginal distributions of x and y. To find the marginal distribution of x, we fix the value of x and sum the joint probabilities over all possible values of y. This gives the marginal probabilities P of x equals 0 as 2 over 9, P of x equals 1 as 1 over 3, and P of x equals 2 as 4 over 9. We also make the marginal distribution table for x. Similarly, to find the marginal distribution of y, we fix the value of y and sum the joint probabilities over all possible value of x. This gives P of y equals 1 as 2 over 9, P of y equals 2 as 1 over 3, and P of y equals 3 as 4 over 9. We also make the marginal distribution table for y. These marginal distributions will be used in the later parts of the question. Next, we check whether the random variables x and y are independent. Two random variables are independent if for all values of x and y the joint probability equals the product of the marginal probabilities. To test this, we compare one joint probability with the corresponding product of marginals. For example, when x equals 0 and y equals 1, the joint probability is 1 over 27. However, the product of the marginal probabilities is f of x equals 0 multiplied by f of y equals 1, which equals 2 over 9 times 2 over 9, giving 4 over 81. Since 1 over 27 is not equal to 4 over 81, the independence condition is not satisfied. Therefore, x and y are not independent. Next, we find the conditional probability that y is less than 3 given that x equals 2. By definition, conditional probability is given by probability of both events divided by the probability of the given event. In this case, y less than 3 means y can take the values 1 or 2. Therefore, we sum the joint probabilities when x equals 2 and y equals 1, and when x equals 2 and y equals 2. From the joint distribution, these probabilities are 3 over 27 and 4 over 27. The denominator is the marginal probability that x equals 2, which is 12 over 27. Dividing the numerator by the denominator gives us the answer 7 over 12. We move on to part E, where we are required to find the variance of x and the variance of y, and then use this result to evaluate the expected value of 4x squared plus 6y minus 2. We begin by finding the variance of x. The variance of a random variable is given by the expected value of x squared minus the square of the expected value of x. Using the marginal distribution of x, we calculate the expected value of x as 11 over 9 and the expected value of x squared as 19 over 9. Substituting into the variance formula gives the variance of x equal to 50 over 81. Next, we find the variance of y using the marginal distribution of y. The expected value of y is 20 over 9 and the expected value of y squared is 50 over 9. Applying the variance formula, the variance of y is also equal to 50 over 81. Finally, we evaluate the expected value of 4x squared plus 6y minus 2. Using the linearity of expectation, this becomes 4 times the expected value of x squared plus 6 times the expected value of y minus 2. Substituting the values and simplifying, we obtain the final result 178 over 9.
My name is Siti Nakibah. I will proceed to present in detail question number 2, which deal with the joint probability density function of the random variable x and y. Question 2a, find the value of k with joint probability density function of x and y. For this function to be a valid probability density function, the total probability over the entire domain must equal to 1. This requirement is expressed by the double integral. First, we can integrate with respect to y, and then we can integrate with respect to x so that we can get the value of k. Since k must be positive, therefore k is equal to 2. Question 2b. The marginal density of x is found by integrating out y. With k equal to 2 from a, we can substitute function x and y, and then we can factor 1 over 3 out. Then we can integrate with respect to y. The final answer for marginal distribution of x is 2x power of 2 plus 2x over 3. After that, the marginal density of y is found by integrating out x. Substitute f(x) and y and factor 1 over 3 out and integrate with respect to x, and then we can get the marginal density function of y is equal to 1 over 3 plus y over 6. Question 2c. Determine whether x and y are independent. Use the formula fxy equal to marginal x multiply marginal y is independent. At this, we can see marginal x multiplied with marginal y is not equal to fx and y, so that x and y are not independent. Question 2d. Find the mean and variance of p equal to 6x minus 3y plus 4. Use the marginal x and y from the past answer and find the mean of x and y. We also must to calculate the mean of x power of 2 and mean of y power of 2 to calculate the variance. Find the variance of x and variance of y using the formula above. Since x and y are not independent, we must find the covariance of x and y. Now we can find mean of p is 5 and the variance of p is 193 over 245. That's all from us. Thank you.